Hi again. This is part 2 video of engineering economic analysis. For some of you, they had watched the previous part and we talk about several topics regarding engineering economic analysis. In this video, we're going to describe and talk about part 2 of this series. Let's go back and try to check what was studied in the first part. In the first part, we talked about definitions regarding the engineering economics. We talked about the simple interest, compound interest, and present value with the future value. Then we talked about the single payment formula and tables. We also spoke about the net present worth, the cash flow diagrams, and the alternative investments. In part 2, we're going also to talk about some sort of payment methods, which is the annuity, which we call it also uniform series, and the gradient, which is also sort of series, but it's increasing or decreasing payment method. So this is basically what we're going to discuss in part 2. However, there will be a video on part 3 and the topics still not yet agreed. Before starting with the main topic, let's again go through and roll back to the definitions. Those definitions were presented at the video number 1, but we'll also try to refresh those terms. P is the value of money at present, which is, we call it the present value. F is the value of money in the future, which is future value. A is the annuity, and G is the uniform or arithmetic gradient amount of payment. I is the interest. K is the number of compounding periods per year. It can be one, which means one payment per year, or it can be several payments per year. Some of the banks usually they use the quarter annual, so K will be 4 numbers. N is the total number of compounding periods. Let's say you're paying on 6 years. Okay, so N will be 6. R is the nominal annual interest rate. MARR, we call it the minimum attractive rate of return, which usually should be set by the investor or by the bank. B is the benefits or the income. C is the cost or expenses. This diagram shows us all the possible payment methods which we can discuss for today. As we spoke before, we discussed the single payment method, and we discussed the single payment based on the present worth, which is we were having P, we find in F, and then we were having F, we find in P. In this part, we're going to discuss 6 payment methods, which is 4 on the annuity and 2 on the gradient, the last 2. We will show you another slide where we can explain the topic more in depth. First, let's put the definition of annuity. What is annuity? Because a lot of you are still wondering what does annuity mean. Annuity is a uniform series of payment. So as it's mentioned in the first line, it's a uniform series of payment. So let's say you're going to pay a loan of $60,000 on 6 years. Every year you have to pay $10,000. This is an annual, this is a uniform series of payment. Let's just go through the definition as is. Annuity is annual amount of payment. It is a uniform series of end of period payment or receipt. Means at the end of each year we have to pay it. Of end of period means at the end of each period, let's say, not to say year, at the end of each period we have to pay it. So this is annuity, and it should be equal. So it should be uniform and it should be paid at the end of each period. What are the four possibilities of annuity? Next diagram will explain it more. So if we have f, which we said the future value, and we're trying to find a, this payment method we call it sinking fund deposit. And this is the formula. Don't bother now about the formula. We're going to show the tables. The tables are more easy to calculate, but still we have to put the formula for the people which are interested to apply in the formula. There is another advantage of the formula when the tables are not having the exact interest rate which you are looking for, so you can also use the formula. So this is the first situation, which is f finding a. Second is we have p, we're trying to find a. This is called the capital recovery, and this is the formula. Then we have a, and we're trying to find f, which is opposite of the first one, number 1, and this is number 3. Okay, this is called the compound amount, and the last is a finding p. So we have the annuity, and we're trying to find p, which is the present value. This is, we call it equal series present worth. Let's start with the first scenario, which is sinking fund, or we have f is defined, and we're trying to find a. So this is to calculate the amount needed to be invested each period in order to generate a specified amount at some future date. So we have the future date, and we have the amount which should be generated, and we need to calculate the amount needed to be invested at the end of each period. So the amount needed to be invested at the end of each period is A. So we're trying to find A. Let's put this into an example. One of the examples which is very common for this payment plan is retirement investment plan. Retirement investment plan, you have the future value, and you know when you want this money, and you're trying to find A. In case you need to collect an amount of $1 million at the age of 60, while your age now is 40 years, with an annual interest rate of 10%, what would be your yearly payment to achieve the target amount? So we have the target amount, which is 1 million. This is F. And we know the period, which is 60 minus 40, because this is the target age, and this is today age. And the interest rate, which is the attractive interest rate for us, is 10%. What would be your yearly investment? Let's solve this example. So we have the formula. We try to put the formula first, then we can also use the tables. So the formula is f into I over, open a bracket, 1 plus I into the power n minus 1. So the unknown is A. F is 1 million. The period is 60 minus 40, 20 years. I is 10. You have to substitute in the formula, and you can get the answer as shown. Don't forget, never put I as 10%. Usually you have to put it in the decimal form, okay, which is 0.1. Fine. So the amount which we need to invest it yearly is $17,000, 459.6. Now the second example is on the capital. The capital recovery is to calculate the amount to be recovered each period from an investment in order that the invested capital can recover a specified rate of return. What does it mean? So we invested a capital. This is P. When you invested means at present means this is P. And you're trying to recover this capital. How are you going to recover it? You have the rate of return which is acceptable for you. Usually, the investor has to set this rate of return, or he has to compare it to the easy way of rate of return. He can compare it to the bank. Let's say the bank is giving him 10% on a fixed deposit. So for him, any investment has to be more than 10%, which is the easy way of getting money. So we have the capital and we have the rate of return which is given by him. So he need from us to tell him what is the amount A which is need to be achieved yearly in order to recover our investment. One example of this is loan payments. Usually it's calculated on this formula, and the other one is to calculate the return on investment. As we said, we're trying to recover the return on investment. Example of this payment method: in case you were given a loan of $10,000 on a 5% interest, and this interest is per annum, per year, for a period of 3 years, what would be your yearly payment? So you have to pay back. What would be your yearly payment on 3 years? Let's solve it. Solving this example on the capital recovery, we have the formula and we're going to do it on the table also. So as we said, we're finding A and P is given in the 10,000. Let's substitute. When you substitute in the formula, you'll achieve the amount of A, which is 3,672.09. This is the amount which should be paid every year to achieve this percentage and to recover the 10,000. Let's also solve it using the tables. As we said before, the tables usually it's an easy way to find the unknown, which is can be A, can be P, F, whatever. But we have to be very careful about which notation we should use. So now we have the N, which is 3 years. First of all, you have to find out the correct table. This table is for the 5% interest rate. It's not shown in this screenshot, but this is for the 5% interest rate. So we have to open the table on the 5%. Then we have to go to the row N, which is 3. Then we have to select the correct notation. The correct notation, as I will show you now, since we are always try to write the formula or the notation, we are finding A, so we have P. Write A equal P, then open a bracket. A at the beginning, then you have to put A at the beginning over P. So A over P is this one. Since we put A at the start, put in the notation A over P. Okay, so use the A over P. So the factor is 0.3672, and if you apply, you get the same value, which is 3,672. Now for the people who does not have the tables, they can write me in the comment line. I will send it to them, or they can also search for the tables of interest rates. Now we're talking about the third payment method. This is the compounding amount. The compounding amount, as we said before, we have A, we're trying to find F. This factor gives the amount generated by an investing a regular sum. So we are investing a regular sum, which is A, right? Each period for a specified number of periods at a given rate. So we have the interest rate, we have A, we're trying to find what would be our total future value. Example of this thing is calculate your total future value of a regular investment. Simple. Let's say your bank having an option to invest yearly 10,000 for 5 years, okay, in a fixed deposit in order to grant you a 6% annual interest. So your bank usually is not giving 6% interest, but he offered you, if you keep your investment 10,000 yearly, every year you have to put $10,000 for 5 years, I'm going to grant you the 6%. So this is A, because every year you're going to pay this, and this is the period, and this is I. Okay, we'll solve it on the formula and notation. Apply the formula, 10,000, apply I and N and everything, you're going to get 56,370.9 at the end of 5 years. Okay, now same, open the interest rate book, catch the paper which is 6%, okay, and go to the row which is N, the number of periods, 5 years, okay, and catch F over P. Why F over P? As we said, you're finding F, you have A, so open the bracket, write F first over A. So this is F over A. F over A, N, catch the factor and apply it, 10,000 into 5.637, it's the same value which we calculated before. The last payment method on annuity is present worth of regular series of payments. This factor gives the amount at present for an equivalent series of payment investing regularly for a specified number of periods. So it gives the amount at present. This is the amount at present. So we are trying to find A, right? And we have the period and we have the annual payment, the series of payments. Sorry. Okay. So example of this thing is the long-term fixed deposit or anything in the sphere of deposits. But I tried to give a different example just to try to make it a little bit challenging. If we said a car showroom gave you 2 options to buy a new car. So we have 2 options. First, pay for 3 years a regular amount of 5,000. So every year you have to come and give them 5,000 for 3 years. Or pay today 14,000. What would be the best scenario? Usually, okay, let's assume that the money is available with you. Because, you know, some people will say to me, I cannot pay the 14,000 today. So for sure, I'll go for the payment of 5,000 yearly. No, we will say that this example, the money is available in your pocket and you have the 2 options, either pay 5,000 on 3 years, which is going to collect 15,000. This is if you are going to just use the normal way of calculation. You're not allowing the annuity or the percentage of interest. All this thing, you're not factoring it. So just the normal people will say, no, I can pay maybe 14,000 today and it's cheaper for me. This is not the way to compare. You have always to allow for the interest rate. So let's continue in this scheme. Which scheme you should choose, considering that the full amount is available with you and considering that your bank can give you an interest rate of 5%. So a person who wants to do a judgment on this, he has to consider that if I have the 14,000, I can maybe put it in the bank and get 5% per year on fixed deposit. So what would be the best scenario for me? Let's try to solve it. So in this one, we're trying to find P. As we said, we have A, which is 5,000 per year. So, okay, this is wrong actually. This should be P. P equal A over P over A. So this is P. We're trying to find P. So the value of P, which is P1 after applying the formula or notation, is 13,616. That means if you pay at the end of each year for 3 years 5,000, the value of this money at present is 14,000. Today, sorry, 13,600. This value of money is 13,600 because you're paying it in the future. There is the interest and there is the depreciation. So P1 is 13,600, while P2, which is the direct pay today 14,000, is 14,000. So which scheme you select, which scenario you prefer? For sure you have to go for the first scenario, which is, let's go back. First scenario was paying 3 times 5,000 every year. At the end of every year we'll pay 5,000. Okay, so by this we finished the annuity payment methods. We will talk about the gradient series. It's similar to annuity. The only difference is that the payment is not constant, is not uniform. The payment is increasing or decreasing. So what's the definition? The gradient is a series of payment increasing or decreasing according to a fixed increment. So the most important that the increment is fixed or arithmetic change. What does it mean? It means that the payment can increase or decrease, but the stepping is constant. So it can increase yearly by 1,000. It has to continue increasing by 1,000. We have two scenarios of gradient. G is available. We're trying to find P, or we're trying to find A. Those are the two options which I read in the books. Maybe there is another possibility, but you know, they are not so much familiar. We'll try to solve two examples on the arithmetic gradient. Before going to the example, let's again just to explain what the uniform increment is meant. Like this scenario, you have at the first year 100, 150, 200 and 250. So the increment is 50. The increment is uniform. The payment is not uniform. The payment is increasing, but the increment is uniform. So this is what called gradient series or arithmetic gradient. Okay, very important to try to explain this part. Now at the first payment was not 0. So at the first payment you're paying 100. Then the increment starting. So the increment starting after this rectangle. What is this rectangle? What is this payment? This payment is annuity. Annuity at $100. Okay, let's solve one example. Considering the following payment, calculate P, okay, the present worth, if I equal 4. So we have the interest rate is 4 and we have 5 payment. So we have N equal 5, right? And we have this payments. At the start, to know what type of formula you should use and what type of payment series you should use, I prefer to draw the cash flow. The first year is 250, second is 300, 350, 400, and 450. So, as we can see, it's an increasing payment and it's increasing uniformly. Why? Because the stepping is 50. 50, so G equal 50. What about this part? As we said before, this part is going to be annuity at 250. This full part is annuity. Yes. So divide the solution into two parts, part 1, part 2. So we're calculating P1 and P2. Total P, which is the present worth, is P1 plus P2. P1 is based on annuity and P2 is based on gradient. Apply the formula or the notation and calculate. You will find that we will try to apply P, which is the total P1 plus P2 equal. 250 is the annuity, right? As we said, we're finding P, so put the notation P over A. This is the P over A, and this is the table for 4%. And we're trying to find P over A, and N equal 5. So where is N equal 5? This is N equal 5, right? Okay. And same way, 50 is the gradient because the increment is 50. P over G, 4%, and N equal 5. G equal 8 the notation equal 8.5. Apply 250, which is A, into 4.45. This one is same, this one. This is same, right? Plus 50, which is the gradient, which is the arithmetic change or jump, which is 50, into the factor, which is this one. Since we are calculating P over G. So the total payment or total present worth equal the sum of these two formulas. 1540.75. We reached to the end of part 2. Please keep watching my videos. I'll be posting part 3 soon. Hopefully this part could brought benefit for you, and I'm waiting for your comments on this video. Thank you so much.